When a machine unexpectedly dies on the factory floor, operations halt, and the business starts burning cash by the minute. The required cure is an upgrade to predictive maintenance. This means installing physical IoT sensors on the aging equipment and writing software to link them directly to the factory's SAP FICO database, so maintenance teams know a breakdown is coming before it happens. But before engineers can calculate the total project costs or run complex engineering economy formulas, a strict operational timeline must be mapped out. Executing a high-stakes hardware installation across an active factory floor without a precise, locked-in schedule guarantees operational collapse. Open Microsoft Project on your workstation and select a blank project. Think of this blank slate as your tactical command center. Navigate to the Project tab at the top of the interface and click Project Information. Here, designate a definitive start date for the operation, such as next Monday. Next, look to the bottom left corner of the screen. You will see a status bar set to Manually Scheduled. Click that toggle switch and lock it into Auto-Scheduled. Forcing the software into auto-schedule mode strips human math errors from the timeline calculation. It allows the program to dynamically adjust dates and measure risk as the operation evolves. A massive hardware integration is too complex to track as a single objective. We use a work breakdown structure, or WBS, to slice the operation down into actionable, controllable pieces. This hierarchical flowchart maps out our project starting from a single core node, branching out into 4 primary phases: planning and design, procurement, execution and installation, and testing and commissioning. Type these exactly into your task name column. Underneath the planning phase, insert empty rows to log the feasibility study and management approval. Below procurement, insert rows to record purchasing the vibration sensors and acquiring the SAP FICO licenses. Finish the list under the execution phase by defining the machine downtime, sensor installation, and database linking. Finally, under testing, log the physical test runs and the required operator training. At this stage, your software screen displays a flat list of text. The system does not yet recognize the structural relationship between these items. Highlight your detailed subtasks, navigate to the Task tab, and click the green Indent Task arrow pointing to the right. That single indentation links the specific actions underneath their parent phases, transforming disconnected text into a rigid hierarchical command structure. With the structure built, we focus entirely on the time constraints. We must define exactly how long each piece of the operation requires to complete. This bar chart displays our early phase estimates. Notice how a tiny one-day top management approval is completely dwarfed by a massive 14-day wait for the physical sensors to be shipped. Enter these specific durations into the corresponding column. Continue populating the grid with the remaining times: a strict 2 days to physically install the sensors on the motors, and 4 days to configure the data pipeline into the SAP software. Do not manually type durations into the 4 main phase summary rows. Leave those entirely blank. By isolating your duration and lists strictly to the detailed subtasks, the project management software automatically aggregates the total temporal cost of the entire operation. A project operates on physical reality. You cannot install a vibration sensor on a pump if the hardware box has not arrived yet. Click the gray task number box for your first action. Hold the Control key on your keyboard and carefully select the subsequent tasks in their exact chronological sequence. Go to the Task menu and click the chain link icon. This will permanently connect the operational sequence inside the software. Defining these dependencies enforces strict chronological constraints onto your plan, preventing impossible scheduling overlaps. This cascading sequence on the right side of your interface is a Gantt chart. By linking the dependencies, the software generated this descending staircase pattern to visually map your operation. Now run your final verification checklist. Confirm 4 main phases, indented subtasks, assigned durations, and a descending Gantt cascade. Lock down your progress immediately. Save the file using the strict required naming convention, group number _IoT_project.mpp. This time-secured, structurally sound schedule is the required baseline. You will rely entirely on this file to assign specific financial costs and labor rates in next week's lab.